Hi everyone, welcome to this session on computer science basics for backend developers. I think there can be various ways of understanding this topic, but I thought I'll just make things a little spicy for you guys by bringing a very different discussion and then connecting that to backend. Okay, let me put a scenario before you. There is one member in the Deep Thought team who's super comfortable with Google Sheets. He likes to think in the form of Google Sheets and he writes everything on Google Sheets. So that is because he's able to think very quickly with Google Sheets. Now, recently he was asked to communicate to some parents about a course that he's taking for children, and he makes it on a Google Sheet and he shares the Google Sheet to the parents. Now, parents are more comfortable reading it on a web page where everything is on one page than through Google Sheets where navigation is not that easy for them. Or in general, very few people are comfortable with Excel-based navigation. So what do you think is his mistake? Was his mistake to make Google Sheets? Should he have put all the information directly on a website instead of using Google Sheets? Was his mistake usage of Google Sheets? What do you guys think?
I think his mistake was he couldn't understand how the parents thought. He didn't know that the parents could not understand Google Sheets that well. So he knew that. Then,
what do you want him to do then? Do you want him to stop using Google Sheets?
no, he can use Google Sheets, but he should display it in a different way to the parents.
So then double work, no? One on Google Sheets and the other one maybe a PDF or a PPT where parents can see. Yeah, Aryan? Can you keep your mic closer, please, Aryan?
Now can you hear me?
Yes, you're audible. Please go ahead.
Okay, so he can think and kind of write the content on Google Sheets and then directly change to a web page format.
Then that's double work, no? He has to do it twice. Once on Google Sheet and once on web page.
You could just copy paste it and put it in.
Still, that's two efforts, right? Why would you want to take that effort twice?
He could then just directly do it on a presentation. Okay, not a presentation, on a web page, because. Okay,
what does he lose out if he doesn't use that Google Sheet?
The structure to think from.
Easier for him to think, right? Now, in the same way, when you take a restaurant, would you want to cook and also serve in the same place, or would you want to cook separately and then serve separately?
Serve separately.
Why wouldn't you want to cook in the same place where people are eating? Cook right in front of them.
I think there would be a lot of smoke and it could probably be disturbing.
Okay. What becomes important in a place where you're cooking?
Cleanliness.
The ability to create that food, right?
Okay.
What becomes important in the place where you're serving the food?
Eat and display it.
Peaceful place to eat.
The experience which the person is getting while eating that food, right? See, you buy a sandwich on with a roadside eatery, you might get it for 20-25 rupees. Go to a decent eatery, they may charge 40-50 rupees. Right? You go to a premium place, the same club sandwich might be sold for 900 rupees. So the quality of the experience is adding that to that value of that sandwich, right? So when you're serving the food, you're interested in the experience, how that person is experiencing that value, right? And when you're creating that food, you're more worried about how you get the job done. So likewise, now let's ask a more fundamental question. When we create technological applications, okay, let's ask this question, right? So there are bakeries which bake breads and, they bake bread and they sell it in their own bakery. Now, if you look at it, there are some bakeries where there was central kitchen for the entire city. They make stuff in the central kitchen and they send it to all their branches in the city and they sell. Why do they not make food in each and every branch? Why do they make it in the central kitchen?
Maybe
One
they
thing,
would have to invest a lot if they're having individual kitchens in every restaurant.
You're making, like, let's say you're making 100 sandwiches for each branch. You're making 1,000 in a central place. Making 1,000 in a central place or making 100 in 10 branches, how is it different?
the scalability, as the scalability increases, the per unit cost
What is the
decreases.
major difference? 100 in 10 branches and 1,000 in one branch.
You have to transport all of the raw materials to all of the branches.
Exactly. Then it's better to do it in 10 branches. No, why would you do it in a central kitchen?
Because you kind of invest more on making it.
The equipments you require are
Okay, equipment then.
Also,
Quality being saved.
Also this the space. I think if you have a central kitchen, we can have more space for more customers in the individual places.
Experienced person is there to make.
Exactly. You have one person who's leading your efforts. That person is on the floor and making sure all the 1,000 sandwiches are made well. You make that one place so good. You give the best infrastructure there. You give the best one place so good. You create everything in one place. Then you can always distribute it to different places. You look at Pepsi and all these guys, right? You make the soft drink in one place, one bottling unit. You do the dilution in one bottling unit and you distribute it everywhere else. So if you look at it, after the industrial revolution, please understand one thing. Before being a software engineer, you're an engineer. Understanding engineering becomes important before understanding software engineering, right? So as an engineer, it becomes important for us to understand industrial revolution. So with industrial revolution, what is happening? Instead of things being made in one place, what is happening? You started making things in a factory. So because you're producing in large volumes, you produce much better quality at a lower price. Look at your t-shirts, look at most of the things we consume today, they're produced in one factory and distributed to us, right? So the place of creation and the place of consumption are not the same. Why? Because the place of creation is having some specialized creation capabilities. Well, the space of consumption is creating a nice experience for me. On the other hand, if you think about it, if you look at the example of a fridge, before the fridge was developed, what used to happen? People used to buy ice. They could not make ice at home. They would buy ice. But after the fridge was made, what happened? You make your own ice at home. So technology can also give you that power to make what you want in your own place without having to wait for a central kitchen to give you that. But even here, what are you doing? You're making that refrigerator in one place. You're not making it in the client's location. You're not making a refrigerator. You're making it in a factory because you need the equipment to make it. And you need that operation staff, right? That manufacturing staff to oversee that the machines are used properly. That itself is a hectic task, right? To run that factory really, really well, maintain quality in the factory and so on. So what did we see so far? I have a specialized space of creation where I have the creation capabilities and I have distribution. Through the distribution, there's a specialized place of consumption. Is thread number one clear? Thread number one is industrial revolution has led us to move everything to some centralized places of creation. This is thread number one. I've not come to software yet. I've only come to engineering. Now thread number two. Now we'll come to software. Now, if you think about it, today, let us say Ronak wants to buy some juice or Ronak wants to buy some vegetables. His parents have asked him to get some groceries. And Ronak knows it's not urgent. and he doesn't want to step out of the house. What does he do? Dunzo, Amazon, Flipkart, Big Basket. So what are they telling? They're telling Ronak, I'll use technology to solve your problem more efficiently. Okay, tell me, how do these grocery apps make Ronak's life, bring efficiency to Ronak? Why is Ronak willing to pay them a premium rather than going and buying from the nearby supermarket or somewhere?
They save him the time which he could use for
Saving time, fine. One way of adding value.
Quality products.
So
You'll get the same quality products in a supermarket, no?
There is more variety.
More variety, saving time, more variety, then
Plus, they give you
As
at
the-
your doorstep.
reviews,
Yeah.
okay?
As they buy in bulk, they can give you discount also.
Okay, yeah, pricing can be better.
Offers can be there.
Yes, Srijit, yeah, return if that's not good. So technology is making that. See, there was a traditional process, okay? There was a physical process. That physical process was digitized. Why was the physical process digitized? To create more value. Okay, let me tell you some stories from Thomas Friedman's book. Sorry, Milton Friedman, yeah. The World is Flat. Brilliant book about the BPO industry in India. Now, if you think about it, if you're a CEO of a company in the US, you have a client presentation in the morning tomorrow, and you need someone to make a presentation, you know the points, but you don't have the time to find some pretty pictures, make it nice and make a presentation. What can you do? It's late in the night, people are about to go sleep. Ask one of your employees to stay up late night, make the PPT and give you by tomorrow. Or what else can you do? A better option.
Outsource.
Huh?
Outsource to, like, as they do outsource to India. Like,
You
I can
ask
think about it.
somebody in an Indian office to do that for you.
Yeah.
It's day in India. So it's night in US, but it's early morning in India. The guy takes the email, gets the brief. Okay, fine. I'll give it to you in the morning, he says. But for him, it's the morning. So this guy, takes 8 hours, completes, about to leave in the office in the evening, sends an email to that guy. That guy wakes up, gets the mail, takes the PPT, goes to present. So can the PPT be made only in America? It can be made anywhere in the world. Another question. Let's say it's late in the night at 2 o'clock or very early in the morning at 2 o'clock in US. There's a medical emergency, has to be attended to very quickly, and there's no doctor available, no way to get a doctor. Don't tell me helicopters and all, no way to get a doctor. Okay. But there's a nurse who's available. The nurse can treat the patient provided the nurse gets instructions on how to treat the patient. So what do?
video call to India.
Yeah, 3 Idiots mein they showed, no? He does a video call, right? So in both the cases, the work can be done anywhere in the world. When can the work be done anywhere in the world? If the work can be
Like distributed.
digitized.
Digital.
If you can make your work into zeros and ones, that work can be done anywhere in the world. Today, why do we have a huge requirement for software engineers? Because this is the power and possibility that software engineering gives to business. Because if something can be digitized, it can be done wherever it is cheapest and the best. Globalization, right? Can go to that country where this can be done the best and you get it done. If you think your UX can be done best in Europe, you go to Europe and get UX done there. You think your customer service can be done best in some other country, go there. You think PPTs can be made best in India, you come here. So you go wherever that work can be done in the lowest cost at the best quality. So first we said the engineering phenomenon, industrial revolution. We wanted a centralized place of creation. And second one, what did we say? Digitization. Because digitization can distribute the work and also bring efficiency to the work. That's why you have fintech, agri-tech, ed-tech, health tech, entertainment tech, prop tech, that is real estate, property tech. Yeah, deep third is talking about peda tech. So there are various kinds of tech. It's just tech all over the place, right? Insurance tech, fintech. I mean, so much of technology coming in. But fundamentally, why is this technology coming in? A, it can be done anywhere in the world, and B, it can be done more efficiently. So what was our thread one? Engineering. We wanted to move to one specialized place where the things can be done. Why did we move to a specialized place where it can be done? Why did we move to one central kitchen or central factory and so on?
So that there's a more specialized place. There'll be better quality creation and high volume.
Better quality creation at a low price. You bring a lot of efficiency, but the price comes down, right?
Right.
See, you look at a Britannia, a normal bakery can never compete with a Britannia on price. Because when you produce in so much volumes, your suppliers give you goods at low price. The wheat and all of that, you get it at a very low price if you're Britannia than a local bakery. And your existing workers produce so much of quality. You can invest on machines. Those machines again cut down your cost of making. So because you're making in such huge quantity, you cut down your price in a big way and you increase your quality. So our thread one was, we are interested in making sure that there's one specialized place which is making it in the best way. Second is, we are saying we want it in a digital way because it can scale and it again brings more quality at a low price. Now coming to the third segment. Let us say you're a customer, you want to buy some goods. Like if you're Ronak, you want to buy those carrots. That computation of which carrot is good for Ronak, would it be better off? So now I'm a company which can guide Ronak in where to buy. And once Ronak decides where to buy, let's say I'm Amazon, I don't deliver. I have a tie-up with say delivery. I have a tie-up with delivery or Dunzo or Uber, Ola or any of these guys, okay? So what Ronak does is Ronak places an order on my platform and then automatically Dunzo gets a notification and Dunzo picks it up and delivers it to Ronak. So all I'm doing is I'm advising Ronak on which one to buy and I'm giving him choices. So when I'm advising Ronak, do I advise Ronak from my computer, where my computer does all those calculations and advises Ronak? Or would it be better off doing this computation on Ronak's computer, his laptop or his mobile?
I think on our end, because we already have lots of data of other customers which we can push to Ronak.
Are you going to push all the data to Ronak?
Not necessarily from
Exactly, right? So why is it that we don't do this computation on Ronak's computer? Why do we do it on our computer?
It saves Ronak's time at first. That in like we give him choices about
So you
options.
load everything on his computer and you run and give him what he wants. No. Like if you think about it, WhatsApp is storing your photos on your computer, not on their computer. Why can't I use his computing resources to do it? Do you get my logic? WhatsApp is storing your images on your phone, no? And if your phone runs out of it, where is it doing backup on your Google Drive, no? WhatsApp is saying, I'm not going to give you storage. So why can't you use your client's computing resources? Why are you going with your computing resource?
In this case, you need data of millions of users.
Which he may not be able to store, and that's my private data. I'm not interested in sharing it with him. Because that's what my business thrives on, right? So I want it on my computer for safety reasons. Second is it's too much. His computer may not have that much memory. Third is, will his computer have that much processing power to do so many calculations so quickly?
No.
It's like, why do I make the car in my factory? Why don't I make it in your house?
Because my house is not capable of making such.
Why is it not capable?
For the requirements the product needs.
Equipment, right?
Equipment, space, and
If
quality.
an electrician comes to your house to repair something, Certain repairs, he comes with a toolbox and he repairs and goes off. But what if it's an advanced repair? He says, I will go to my workshop and come back, right?
Yeah, we have to go to.
So your backend computation is basically where you're building your specialized computation capabilities. Does that make sense? And this thought comes from industrial revolution itself, right? Because in industrial revolution, you saw a lot of factories coming up. You saw specialized production at a huge scale where people are capable of producing more value. Do I make sense? And you've converted this to a digital format. Why have you converted this to a digital format? Then you're able to run sort of algorithms on it and make it efficient. So your backend is a place where you have this specialized computation which is going on. And what would be your database? Database is like your warehouse, right? Backend, you can think of it as that equipment, infrastructure, workers, and the capability to work. But your database is like your warehouse. If my factory only has the equipment and workers and doesn't have a warehouse, is that good enough?
No,
Why?
because where will you store large amounts of your finished goods?
Let's say I ship them immediately. I don't hold finished goods. Then
But you need raw material to store.
I'll take raw materials only when I need them.
You need some amount of still you'll
Why I need some amount? Let's say I'm a bakery. Why do I need to store bread? I'll get bread when I have to make it. Your production will get slow. No, they have to wait for the bread to come.
Yeah.
So then if you think about it, my database contains some data. Even though I can get that data on demand, I need some data with me, right? And also if you are producing, see, let's say you're a bakery where you're producing your own cakes yourself. You're a bakery, you're producing your own cakes yourself. You're a bakery, you're making a wheat yourself. You have your own fields. I was told there is one hotel in Tirupati where they have their own dairy farm. They have their own farms. They grow all the raw materials in their own farm and they get milk from their dairy farm and they serve people. And it's like a very well-performing hotel because people feel that, this place, the food is very clean. Because the complete supply chain is controlled by them, right? From the milk, how they raise the cows, to how they grow the raw materials and so on. So if you are a super specialist company, you want to hold on to the data, and the data is your gold mine, right? I mean, who better than Mark Zuckerberg knows the importance of this? World's best data salesman, world's best privacy salesman, right? So now, do we understand the importance of backend and the importance of database? So why is data important? Let's understand this. Somebody was talking about Zomato's initial revenue model. I'm not sure if they had it, but somebody was thinking of a revenue model for Zomato. If you are Zomato and you are listing different restaurants and different people can go review restaurants and so on, you know what people are buying in different places. You know which menu people are interested in. You know in which location restaurants are being successful and so on. And now let us say Abhishek wants to set up a new Chinese restaurant in Delhi. Can Zomato help Abhishek? How?
They can give the data
How?
according to the orders they already have. They can go for the preference of the current customers.
Correct. You can say that Abhishek, your restaurant is 2 lanes away from the main road. Our research shows that only the restaurants which are 1 lane away or 5 lanes away from the main road are successful in Delhi. Does that make sense? The location, how close are you to the main road? What items are you placing? What is the pricing How much are other people pricing this at? You have huge volume of data. You can convert the data into intelligence. So if you're a backend developer, you'd want to understand the business context. If you want to understand the business context, you'd want to understand, how does my customer buy? What makes my customer successful? What's the question we're asking? What's the question?
What my customer wants to
What
buy.
makes my customer successful? Know your customer's business really, really well, and ask what makes my customer successful. Then you ask, what data do I need to do that intelligent decision making? Do you guys get what I'm saying? You understand the world of your customer. Let's say your customer is a patient who's going to see a doctor. Then what do you ask? What makes my customer successful? What makes your customer successful?
Getting treated.
Sorry?
Getting treated.
If your customer is healthy, that's when your customer is successful. Now, how can you make your customer healthy?
Again, need some data over customer. Like
You
if
need
the
a good
customer is
doctor.
healthy.
You need a good doctor to be helping your customer. Now you need to send your customer to the doctor. To send your customer to the doctor correctly, what data do you need?
Location of hospital.
What kind of problem is the guy suffering? So you can decide which kind of doctor he or she needs. But the person may not know that, do I need a pediatrician? Do I need an oncologist? Do I need a nephrologist? Do I need a ophthalmologist? I don't know. So you ask a set of questions, and through those questions, you get the data. Do you have a problem with your eyes? Do you have a problem with your throat? Do you have a problem with breathing? You ask questions, and through that data, you find out which kind of a doctor your customer needs. And now when your customer goes to the doctor, if your customer keeps changing doctors, will the doctor find it difficult if the doctor is not familiar with your customer? Why? Your doctor does not know medical history of this fellow, what allergies this person has, and so on. But what if you can collect that data and give it to the doctor? So the doctor can see everything and then recommend the healthcare. Now let's say the doctor is giving a medicine. Now this fellow has an allergy for something. What can the app do? Check if that medicine contains that allergenic substance or not. This adds value to the doctor, right? The doctor might forget the allergies. So for this, what is the backend developer doing? Finding out more about the domain, understanding the subject called healthcare. Once you understand the subject called healthcare, then you're asking, how can I make my customers successful? Your customers are both doctors and patients. To make both of them successful, you started finding out what data you need. Then you build databases where you store that data. Got it? Now, then you also have backend. The backend, Shravan is going to come in and help us understand that better. But your backend where you're doing the actual work, and then you send it to the front end, and in the front end, you're giving the experience to the user. So all the factory work, all the laborious work, where do you do it? On the backend. Like that's like Umang's Google Sheets. Do all your technical stuff on the sheet. But when you give it to your customer with a nice bouquet and with nice color pencils, you wrap it up nicely and give it to the customer. So the customer can, with joy, with ease of use, the customer can use it. So what does the front-end developer specialize in? Delivering the experience to the user, creating happy emotions and a very nice and pleasant presentation. But overall, the front-end developer's job is to create a great experience for the user. But what's the back-end developer doing? Giving all the back-end support, doing all that computation so that the front-end developer with least effort is able to deliver that experience. Majority of it, we'd like to do it on the back-end. Why? It's like doing everything in the factory. Because in my factory, I'm very comfortable working. On the client location, I don't have all my tools. I'm not that comfortable working in my client location. So what do? I do all my work in my factory. So as much as possible, I want to do things in the backend. But let us say I want to give options to my customer. Do I do that at the client location or do I do that in the factory?
That in the client location.
So that it's easier, right? I can show this variant, and so on. So certain kind of experiences, you can only create them on the front end. So you do the computation on the front end. Like let's say Flipkart wants to tell you what's the price of 10 chocolates, price of 20 chocolates, and so on. You know the price of one chocolate, calculating the price of 10 chocolates, you can do it on the front end itself, right? So the user changes the quantity and you tell the price then and there. Because if you do it on the back end, by the time it falls, it gets done on the back end, the front end asks the back end, please do it. The back end then does it. Then the back end sends it back to the front end. You've lost some time in transmission, right? But you do it on the front end, you're giving that experience immediately. But that's an important computation. You may want to do it on the back end because that's where you're specialized. You have your tools there. That's a factory. Going back to the, ice cubes thing and all those things, right? Centralized location, you started doing things because your specialty, your specialized expertise in the factory. But before this, we need to understand that all these things, we converted it into digital data. Why did we convert everything into digital data? To bring in efficiency to the business decision making. Because then your algorithms, your algorithms cannot work with things which is not in zeros and ones. Your algorithms can operate.
Tarun did get disconnected, right?
Yeah.
Yes.
Okay, until he comes back, Shravan, would you like to go ahead?
Yeah, factory where everything is done, right? And front end is the part where only you see the experience. So there are some certain things based on what we actually do this. So we first of all we don't really want to be dependent on the front end. So for example, if you want to do a huge calculation, right? That much, and we exactly don't know what's the user's device capable of. So we best try to do all of these calculations on the back end front instead of the front end. So like the main thing is that delivering that experience. So what if you try to do some calculation that might use up the entire memory of the user? So it would give you a bad experience, right? So we try to keep those calculations on the back end.
Okay. So are we clear on the 3 threads so far? Thread 1 was, we see a specialized factory. That's what industrial revolution led to, specialized factories which are capable of doing some tasks. Second thing was, first one was industrial revolution. Second thing was
Digitizing.
Digitized.
digital revolution, right? Zeros and ones, the BPO phenomenon. What is BPO? Business process outsourcing. There's one place where that process can be done the best. You make it digital, give it to them, they'll do it, deliver it back to you. Is digital faster or traditional mom and pop business faster?
Digital.
You order a mobile phone, you're going to get it in a few days. It has to be couriered, it has to be sent to you physically. But you order something digital. You want a digital service, you get it immediately, right? So as much as possible, we want to move things digital. Can everything be done digital? You can't grow food digitally, no. But what are we trying to do? We're trying to, even in the growing of food, we're trying to make more and more things digital. You understand what I'm saying? We try to make as many things as possible digital, because if I can make it digital, I can improve it. Like the farmer growing food, you digitize that. The farmer is putting fertilizer. You put IoT and you're tracking how much fertilizer. The person has pressed the spray twice and the IoT shouts, "Arey, no, don't, thamba. You already put 2 sprays, not the 3rd spray. The pesticide is too much. Your humidity is this much right now. The pressure is this much right now. For this humidity and this pressure, this much of pesticide is enough. Don't put more." You're calling it smart farming or technology, agri-tech or whatever you call it. What are you doing there? If you can make it digital, you can make it intelligent. So that's the digital revolution. And third part, what did we say? Now, when we are building modern technology, we'd like few things to happen at the client location and we'd like few things to happen at our location. And now we will set up protocols, we'll set up ways in which we want the client and the server to talk. Now, yeah, Sripanna, Anirban, you may have your videos of, no problem with that. Yeah. So,
can you repeat the last one? Like server.
I will repeat that. But just going back to my threads, thread 1 was industrial revolution. Thread 2 was digital revolution. Thread 3 is there is certain things which we're doing on the front end and certain things which we're doing on our back end. And front end, what are we doing? We're trying to, the front end is specializing in creating the
Experience, user experience.
Specializing in what we are really good at. We'd like to do most of the things in the back end. As Shavan said, you're not sure what the computer of the client is capable of doing. Okay. Now, we're moving to the 4th segment. In terms of setting up protocols. When I have multiple computers, there. So yeah, Pooja, showing options and all those things you'd like to do on the front end. See, front end, back end, both have business strengths of the company. The front end strength is your packaging, your presentation strength, your experience creation strength. Your back end strength is your actual functional strength, right? What you're able to do with respect to that domain. So in your factory, you're having the strength of what you're really good at. In the showroom, it's your presentation, how you can make a great experience for your customer to, consume that product. Consumption of the value is happening on the front end. Creation of the value is happening on the back end. I mean, loosely speaking, but there is some value creation happening on the front end also. Now, see, if you think about it, if your application is purely front-end application, then it's not a web or a mobile application. It's a local software you're selling. Do I make sense?
Karan, could you come again?
Not a cloud application, right? It's all working on the front end. It's like I sold you Microsoft Word. You install the software and you use it on your computer itself. You're not connected with me. I sell you the software, you're done. So what did we discuss? Point number 1, industrial revolution. Point number 2, digital revolution. Point number 3,
dividing things between
cloud revolution. Doing things on the cloud. Okay, let me tell you an interesting story. I was telling a story to my friend and he brought the cloud story to it. So it's like, I was listening to an interview of one Telugu film editor called Marthand K. Venkatesh. So he was telling in an interview, he used to do film editing from the age of 16. He used to do film editing from the age of 16. He used to help his father. He said earlier we used to manually cut the tapes and paste the tapes for editing, right? One scene after one scene. You manually put the tapes and you edit. He says, now film editing has changed. We don't do it manually. We do it on the computer. What's the power of doing the film editing on the computer rather than doing it manually?
You can see a preview.
Exactly. You get a preview, right? You have the power of seeing what you're working on.
And the next part is you don't lose your tapes. I mean, they don't get destroyed.
You get the control Z.
Always have to copy.
You get the control Z power.
Yeah.
And yeah, when it's digital, you get so many powers, right? You get the control Z, you get copy paste, Replication is easy, retrieving is easy, multiple options. When it's digital, I'm given so much of power. When it's physical, you don't get that power. That's why many times when you have to do a physical activity also, you first do a simulation, which is a digital activity. Then after the digital activity simulation, you go back to the physical activity. Like if you look at ISRO, they run a simulation of the launch before doing the actual launch because they want to be sure that they're getting their strategy right. Like you're a cricketer, you're playing a cricket shot, you do a simulation. You check if that shot works, then you try it on the ground. Because simulation doesn't cost you much. This is why digital revolution. So we said you have the power of seeing what you're working on. And my friend Kashyap, he hears to the story and he says, now it's no longer digital revolution, it's cloud revolution. You, your producer, your director, everyone in different locations can see what you're working on. The task is happening on the cloud, and from the cloud, everyone else can see it. So you don't need to, it's like cloud is like the factory system for computation. Cloud, you can say, is like a computer factory, right? It's like a factory of computation, which is set up in one place. So you can say cloud is like, I have set up a huge digital factory, which is capable of doing so many processes and so many calculations. You do it here and you take it to your bakeries from here. Your backend is like the biscuit factory, and your front end is like a shop where you're coming and buying those biscuits. The user experience is created in the shop, but the factory is where you're producing all of it. So this is a cloud revolution. So once you're bringing in cloud applications, that's when your front end and back end comes in. But if you're not making applications that are working on the cloud, then it's just an application which is working on your own PC, right? Then there's no need of front end, back end and all, right? It's just one application which is working on your own PC. You just have a local database in your PC. It takes the data from the local database and it shows it to the user and it writes the data to your local database. So does this help you appreciate the value of backend? Backend comes because of the phenomenon of cloud revolution. Why is cloud revolution important? Digitized, all right. Digital revolution alone could have done it. What is the speciality of cloud revolution?
Maybe because we don't need special storage. We have cloud to store things.
Not just about memory. Yeah, yeah, Nirbham.
Even if people don't have the resources to, am I breaking up?
Yeah, even if you don't have the resources, you can do is what you're saying. Okay?
Yeah.
It's something more than that. It's something more than that.
Easy to access?
No. Yeah, you can do things at a scale, but that's not the point. No, easy to spread.
Accessibility and availability of the resources are more better in cloud.
No, but you can do that on by building a software and giving it to people. People will download the software and use.
Yeah, but it will be time consuming, I guess.
Why is it time consuming? I mean, in the early 2000s, all the applications were like this only. We would install it to our computer and we would use. Today's computers have more memory. Today's computers have more power.
It can spread.
Even those used to spread through CDs and all. Through torrents, you download softwares and use, right?
Yes.
See, it's like
I think people from different people from different places can do something together. That oneness can come in.
Correct. Multiple people working together, cloud can make it possible. See, the major thing is you build speciality. You build immense capability which cannot be built at the level of one customer, two customer. See, if you're building for 1 million people, you have so much of resources at your disposal, so you can make the best over there. See, let's say at your house, let's say you have a PhD in microbiology, and in your house you're trying to invent a vaccine for COVID. Is it possible? But here in Shamirpet, 25 kilometers from my house, it was possible. Where one scientist comes back to India and starts a business, and he sets up one of the largest biotech companies in the world called Bharat Biotech, and they make a vaccine. Why was he able? Why is he making that vaccines in his factory? Why is he not making it in your house?
Because the factory has all the specialized equipment needed to produce the vaccine.
Overall, that's a place of excellence, right? You have scientists which are working there, they're building it there, they're monitoring it there. It's a place of excellence which is able to create that value. But where is that value given to you? In the hospital or wherever you go, where the person takes it out, takes it in a syringe and gives it to you, where it's administered to you. The reason why we want to go to cloud is we want to build that infrastructure. We want to build that specialized value creation capability, right? It's like a center of excellence you're building. You're writing so many advanced methods, so many advanced algorithms. You're building so many capabilities which sit on your backend. Now, by the way, I didn't speak about middleware. I didn't speak about controller. I didn't speak about socket. I didn't speak about API. I didn't speak about data model. I didn't do anything of backend. Why are we discussing all these? Software engineering, digital, industrial revolution, digital revolution, cloud revolution. Why are we discussing these?
To get a generalized view of it.
To get an essence of what the backend is.
Once you get the backend, all of these are 5 minutes. Once you get the engineering context of it, these are all 5 minutes. See, most backend developers, beyond a point in their career, they struggle. Beyond a point in their career, they don't get it. Why? They ask the client, what API should I make? What data model should I make? They don't have a brain of their own. Their head has to come and tell, this API I want, this data model I want, and so on. But you will be able to understand things better if you understand the business context. The business context in terms of what is that business doing, what data do I want this business to collect, what processes I want this data to do, how do I make the business intelligent? That's one fundamental question a backend developer has to ask. How can I improve the decision making of this business? What data do I collect and how do I build intelligence out of the data which I'm collecting? What will the front end do? Sir, I have my colleague who's an expert on this. I will tell you, please wait. And then makes a phone call. What's that phone call called? It's called an API. And the colleague over there says, "Nene usko bol dena carrot kharid lena. 15 rupees, 15 rupees. Tell him 15 rupees. And what does this guy say? Front end. After a lot of consultation and after very careful deliberations, my very expert team has feels that you have to spend 16 rupees on your carrot. You getting the model? Someone wants to buy a carrot. Someone wants to know how much do I spend to buy the carrot. The guy makes a phone call to the super specialist which is sitting there, and that specialist says, okay, 16 rupees. Then the front end says, okay, 16 rupees. But so then what does the backend have to do? The backend has to collect that data and build that intelligence so that intelligence can be used by front end to create a great experience. Now, I'm moving to the fourth segment, not a revolution, just a concept. Is, let us say, me and Aryan speak every day. Let's say, yeah, Aryan is a shopkeeper. Aryan is selling raw materials to people. I am at a place where I get to know the price trends. I have to give him, no, let's not take this example. Okay, let's say Shagun, Aryan, Anaka, three of them went to three different markets to buy something. I'm the operations head of my company. I have to buy things, I have to procure things. I'm the procurement head. Let's say I run a large hotel which feeds like 10,000 people every day. I run a large hotel which feeds 10,000 people every day. Anaka, Aryan, and Shagun, three of them went to markets to buy carrots. I'm the procurement head of the hotel. I have to procure things at the lowest cost. Will Aryan go and tell me, Tarun, I went to this market. It's such a beautiful market and I found out the price of carrots. This seller has a very big beard, you know. That beard is a combination of black and white color hairs. And by the way, the price of carrot is 25 rupees per kg. What will I tell him?
You just give me the price of the carrots.
Chup. Price bola bas. What will Aryan do? Call up and say, carrot 25, mango 35, banana 45. I'm like, okay, Roger that. Done. Call close. Call up Shagun. Mango 27. Hold. Mango there 40. Sure. She's like, yes. Are you sure? Yes. Okay. Taken. And then she completes. And then we talk. Someone listens to us and like, what, which language are they talking in? A third person may not be able to understand what we're talking, but we both are able to communicate really well. Why are we able to communicate really well?
Because there's an already set format for how you work.
It's like the context is already known that I want this and you tell me so and so and so.
We want to make this communication efficient, right? To make this communication efficient, the client and server communication, we want to make it efficient. So to make it efficient, now Shravan is going to introduce us to some concepts. But before that, we'd like to also set context for two other concepts of a API and a socket. Now, I'm talking to Aryan. I want continuous updates of what is going on in that location. Let's say I'm the head of Hyderabad City Police, and Aryan is one inspector, and there's a riot going on. I'm about to reach Hyderabad City. I'm outside Hyderabad City. Aryan is in the physical location. Will I be on a continuous phone call with Aryan, or will I keep calling him whenever he needs?
On a continuous phone call because it's an emergency situation.
Okay. But let us say I'm this kind of seller. I just want market updates. Then do I need continuous communication with Aryan?
Not necessarily.
Right. So now when we said that the client and server have to work together to make this cloud computation possible, there are two ways in which the client and server can talk. One way where the communication is there always. Another approach when the communication is only need-based. We will discuss that in a while. But first, I'd like to request Shravan to cover. So Shravan, have we? Okay. Would you want to run us through what a checklist of critical concepts to be aware of in terms of backend and the overall communication flows?
Yeah.
DB, backend, frontend.
DB, backend, frontend, and how the data flows between them.
Okay. And then controllers, middleware.
Yeah. So those things will go come to the backend level.
Okay. Well, I mean, can you go through all the lists, just a checklist so that we are sure?
Okay. So from backend level, we need to know about, I mean, what is a request, what is a response, then what are the HTTP methods, status codes,
okay,
middleware, controllers, routes.
Okay.
Then we have special drivers, like if we want to communicate with any other databases, then we have drivers for them.
Okay.
And yeah, this is it pretty much.
Okay. And this is as far as backend is concerned. Anything else which you would want the backend developers to be aware of?
Well, I mean, where to use sockets and where to use HTTP calls. That's one of them.
Okay, sockets versus HTTP calls.
And some concepts of what's a promise,
Okay,
what's a callback. Yeah, those things.
promise, callback, socket versus HTTP calls, routes, drivers, middleware and controllers. Then
HTTP methods,
HTTP methods and sockets.
status codes,
Okay,
request, response.
okay.
Yeah, and one more thing, that's the express router.
Express
router, that's the main core component of backend.
Okay. So did we cover all of them with this 8?
Yeah, like we have the important ones here. I think like we have everything that we need.
Okay. Okay.
Okay.
So
did we miss the APIs?
Yeah, APIs.
Yeah. I mean, routes are the APIs basically.
Yeah. Yeah. Now let's go over what is a route.
Shall I?
Yeah.
So basically, I mean, routes are those. I mean, what is route? Okay, route is just a roadway. It's a roadway that will connect your front end with your back end. So basically, these routes are the ones that we call them as APIs.
Okay.
So in backend level, we define the routes, and those routes are basically the APIs that we are going to use.
Okay, how do you define a route?
Well, we define a route with the help of the express router.
Okay. What is this express router?
Express router, I mean, express is generally one library that we use in Node.js for setting up a Node.js server.
Okay. Now, what is this Node.js server?
Well, I mean, Node.js is it's a framework that is used to run JavaScript outside the browser.
Okay.
So we can run JavaScript, as you know, we can run JavaScript out of the browser with the help of Node.js. So that means we can also use JavaScript to set up our own backend server.
Okay.
So to set up our own backend server, we use a package or a library called as Express.
So where this is on the cloud, which we own, the cloud, wherever we are setting up a server.
Right. Like first of all, we write the, we make the application on a local and then we push it to our server.
Yeah. Okay. So you use this express router to set up JavaScript on your server.
Well, I mean, JavaScript, JavaScript is the language that we use.
Correct.
Yeah. And Express is a library written in JavaScript.
Okay. Why do you need this Express library?
To set up the HTTP server.
Okay. And why do you need the HTTP server?
Like basically our server has to listen to the request, right? The incoming requests. So to define the routes to make the server listen on a certain port, we use this Express.
Okay. And what does a route need? You're defining a URL for it?
Yes. First of all is the URL. Next, we can pass the middlewares. And
forget
third,
the middlewares for now.
Yeah. Then see the express router. I mean, each route will need two things, and that's the main important things that any route will need. First of all is the route name, and next is the controller or the handler who is going to handle the request coming to the route.
What does the handler do?
Handler basically is the function that is automatically called when somebody hits that API endpoint or the route. So the request has been sent. I mean, the handler accepts the request. Now he can process the request with whatever query or something is coming to the request, or if he wants to fetch some data, he can get it and give you the response.
Okay, so Shravan, can we understand it this way? That so we are into the bakery business. I'm a bakery, and there's a factory. I'm out of chocolates. So I call room number 25 or store number 25 in the factory. So when I call store number 25, there is one person who's a dedicated operations executive, let's say Aryan. Aryan comes there and Aryan takes a request. Request, okay, for 45 chocolates of 10 grams each of this flavor. Then Aryan immediately gives those chocolates back and those chocolates reach me. So there's a place on the server which has to be called. I mean, there's a location, there's a road or there's a path on the server you call.
Yeah.
And you tell them what you want and you tell them what, you give them what you want. You give them something and you
request them
you take
what you
something.
want. And there is one guy who is waiting for you to handle the request, process and give it back to you. That's the person we call controller.
Does the analogy make sense to you guys? So I'm the front end. I use an API. I use something called Ajaxify to call an API.
It's Ajax.
Sorry, Ajax, right? What is it, Ajaxify?
Ajaxify is some custom concept in Node. I mean, the stack we work.
So I use Ajax to make a network call. Means from front end to back end, you make a call. So once you make a call, you want to know on the back end, what is that path where this has to be called, right? Let's say route number 25.
Yes.
Then over there, there's a function or there's a method which is waiting for your call.
I mean, he's not actually waiting, but he gets called when somebody.
Correct. Aryan is called.
Yeah.
The moment you say 25, there's a siren which rings and Aryan comes there. So Aryan, so you're setting up your cloud computation this way, right? You're saying, hey, my front end can call my backend, and when my front end calls my backend, there's a certain guy on the backend who's coming and saying, hey, give me your request. He listens to the request and gives back a response. Just trying to dejargonize all of it, right? Yeah, Aryan?
Like what type of request does the front end send?
Give me chocolates. Tell me what do I do? So, or rather, Aryan, let's ask a fundamental question. Why does the front end request the back end? Or why does the front end need the back end? Why does the bakery need the factory?
To kind of get the essentials to create the experience.
Why does the store need the factory? There is something which I do not have, which I get from the factory, right? So at a conceptual level, there is some specialized expertise sitting in the factory. Okay, let's remove factory right now. Factory makes us feel as though we only go for goods. Let's say there's a laboratory, right? You're a doctor. You go to the diagnostic laboratory. Why do you go to the laboratory if you're a doctor? Why do you call the laboratory?
Because you need a doctor in that.
You need data, right? You want analysis of it. You send the sample gets analyzed. There's some specialized capability in the laboratory which you don't have in your hospital. So I send a request. That is, I send my sample and I tell them what I want with the sample. And I request, I get a response from them. But fundamentally, I'm doing all of these because there's some specialized expertise sitting in that laboratory, sitting in that backend. So I need to tell the guys, hey, I want this, and I'm giving you this. I give you a request. In my request, I give you all the information that you need. And in my response, I get what I want. Now, what if I don't define request response? If I don't define the place where to ask and all?
The process would not be that efficient.
Then I would not be getting what I want.
If Shagun goes to the market, right? Shagun goes to the market. She has the phone in her pocket. She goes to the market. I WhatsApp her and I expect her to immediately respond the price. Is that a good expectation?
No.
Why?
It's not immediate. She might miss out on that message.
I give a WhatsApp call to her. She may not have proper mobile data. I give a phone call to her. Still problematic. Mobile network may not be there. I give her a walkie-talkie. I give her a satellite phone. Then the communication is super efficient, right? So you want to make the client and server communication very efficient. So you're telling that, hey, please go ask here on this URL. And on that, because the moment you ask at that URL, they'll call the right person to come and help you. And the person who has to help you, or the function who has to help you on the back end, what does the function understand? That guy is going to give you the instruction in this format, and you give back the output in this format. That's the request and the response. And why are you using this express router and that routes? Because you're trying to set up that communication in a very efficient manner. Where your front end says, I'm asking this guy. Your front end knows whom to ask. See, it's something like this. You're using the deep thought application. You want to know your thread builder of last week. The app on your phone, does it know where to go and ask on DigitalOcean? It doesn't know. Shavan, correct me if I'm wrong. That's only a URL, right?
Yeah, it's an API.
Okay. Now, if it's a URL, see again, think about it. Aryan, think about it. I change my hosting from DigitalOcean to my own server in my house. I don't trust DigitalOcean. I set up a server in my house and set up all the application in my house. Does your front-end code change? It doesn't change because there's a domain name. So we just go to the domain name and tell her, hey, please don't go to DigitalOcean now. Please go to Tarun's house. So why do we set up routes instead of telling IP address? Okay. Now let's say
IP address may change.
Why will the IP address change?
Like, as we discussed, like it's stored in some computer right now. The IP address for the computer, right? A particular computer.
But for let's say for the next 1 month, it won't change. No, when it changes, I can change all the IP addresses, right?
Like then the repetition, like you need to do it again and again.
Actually, my question is wrong. My question is wrong.
Okay.
If I'm Google, I'm a large company. My code is stored in one IP address. What are the hackers going to try and do?
DDoS it.
Attack me.
They will track the IP address.
Attack me on that server. So what do I do if I'm Google?
I'll have multiple servers.
I'll have multiple servers and it's constantly changing. You don't know which server you're talking to.
The load is balanced equally.
And you know what? Google doesn't do this. Google doesn't do this. They have another company which helps them in doing this.
Yeah.
That company's name is Akamai, AKAMAI. When you load Facebook, right, niche it comes akami.facebook.com or something. They are like the bouncers for companies. Celebrity as bouncers, right? Someone wants to attack a celebrity, the bouncer saves. So Akamai is like a bouncer for the servers of Google and all these guys.
And there is one more approach to do that. Like, what do you do usually when somebody is calling you repeatedly? You block them, right? So we do the same thing. If there is multiple calls from one person, we just block the IP so that he can't attack us.
Yeah. Again, these are all how you bring smartness, because when so much traffic is coming in, right, you want to be intelligent in the way you handle it.
Right.
That is why backend becomes very critical when you're scaling your business. Frontend also becomes critical because you want to give the best experience with the resources. But backend becomes critical so that it doesn't break at a scale. So one thing is when you define a route, right, you have a domain name defined there. You're saying deepthought.education. Today, deepthought.education goes to DigitalOcean. Tomorrow, it can go to AWS. It can go to Tarun's house. It can go to Shaman's house. It can go anywhere. Just have to point it to one IP address. You know, if you guys play with MyTrueHost, you'll understand. You have your domain registrar, right? Somebody who helps you register your domain. The domain registrar's website, you enter the IP address where you want that domain to point to. So when anyone calls for the domain, that domain is automatically pointed to that IP address, and on that IP address, that code is used to serve the HTML page to them on their browser. Is that clear? All of this becomes simple if you understand the main concept of cloud computation. I have something on my end, you have something at your end. And also understanding how internet works. This is how internet works, right? There's a domain name and there's an IP address. When you enter that domain name, what happens? That HTML page which is configured on that IP address in public HTML folder, or how you configure that thing there. Under public HTML, there's an index.html file, and that index.html file is the one which is served to the person who's hitting that route. Am I clear? It's like, see, Saurav is saying, go to hell with DigitalOcean and all. In my house, I will run. I'll buy one computer and run it in my house. So what does Saurav do? On that IP address, Saurav creates a folder called public HTML. He creates a HTML file called rajnikant.html, and he configures saying, if anyone hits this IP address, please show rajnikant.html to them. So what happens? Now Srijit is like www.saurav.education. Then what happens? It goes to Saurav's IP address. And there it says, please go show rajnikant.html. Then Srijit, gets that HTML page, rajnikant.html, mind it, that comes on his page. So this is how the internet is working, right? That he buys a domain, and that is the internet real estate today. Internet real estate, people are buying domains. Some domains are super expensive. If there's a lot of search traffic for a domain, its price goes up. Go to GoDaddy or any of these sites and search the price of some domains. You'll see some domains are super expensive. Why? Because that domain is the one for which traffic is coming, and that traffic is viewing that content there. In a way, domain is that mall where the buying is happening, the front end, right? So you want to sell your thing in the central mall of your city, it's going to be super expensive. You buy a shop in a suburb, rent is going to be less, right? So the domain is like the address where you are storing your thing. If your domain is a highly valuable domain, what does it mean? What does it mean if your domain is a highly valuable domain?
There are a lot of traffics coming in and out.
More people are coming. It's like being in a big mall. Your shop is visited by more and more people. Your experience is given to more and more people. More requests are coming in. Correct. So there's a domain, and the domain is pointed to an IP. That IP is of a server, and you configure that server to handle the requests which are coming through that domain. So that route, may you define that URL where it has to come. So whenever the front end calls that URL, that goes to a function. It's like the front end requesting one particular expertise sitting on the server. It's like, let's say, Aryan and Anaka have written a special function called, let's say, the Ramanujan function to calculate something and give something to people. Now, Pooja is like, I want to know the answer of this question. Then it goes to the backend. It calls the Anaka Aryan function, and that function does the calculation and gives back the response. Then Pooja can see the answer. So there's that specialized expertise through creation of this API, that is a route. I'm able to say, please go to that server. On that server, please ask here. Then the method is called. The method takes the request, gives the response, and then the response is given back to the front end. Clear till here? Now let's go to, so we finished express router, we finished request response, we finished routes. What are the status codes, Shravan?
Status codes are some codes that indicate what happened to this response of this particular API call.
Okay.
So for example, if you hit an API, right? So the API will anyway give you response, but to determine what kind of response is that, we have some status.
Can you tell me the some codes?
Yeah, like 200. 200 means the request is successful.
Okay. Then
300 means this route has been moved to somewhere else.
Okay.
Yeah, 404 means the, I mean,
404 everyone knows.
Everyone knows. 401 is unauthorized, and 500 stands for something bad happened to the server. So the request failed.
So it's again like that Shagun example, right? I'm just saying carrot latest price, and she tells it to me. So the client and the server have a very efficient way of communicating with each other, where you don't have to tell Pura Bhagavad Gita. You tell one number and it understands.
Like in short, status codes above 399 are basically means it's not working. Something is wrong.
So basically, that's like a language which you have given in terms of what has happened. Because irrespective of what API you're hitting, what you know is, hey Srijit, why did you make this request? You're not allowed. You're not a registered user of Deep Thought. How dare you ask this?
Security.
That can be one way. Or what, you're coming back after 5 years. We moved it already. Why are you coming now? A shop has been relocated to some other place. So you have the usual kind of things which happen, right? So that status you're encoding with some numbers. So status codes, there's no rocket science. You go through them and you see it through the larger story of this cloud story which I told you. It's very easy to get what they are. It's basically the client and the server trying to understand what's going on. Where I'm the client, I'm like, I'm waiting here. When are you giving me the response?
Yeah. And
the server is like, 404.
Yeah.
And the client is like, okay, theek hai. So then the front end knows what to do. The front end says, hey, maybe you're not authorized to access this. How does the front end talk about it? Does the front end say, hey, you're not authorized? Or does the front end say, could you please log in to access this page? Which is better? Front end going and saying you're not authorized, or front end saying, please log in to access this page?
Asking to log in.
That is if a logged in user is allowed. If the front end knows why exactly that authorization failed, then front end can say, this is why it failed. Please do this to qualify. But if the front end doesn't know, it failed. Please try this or contact support. So that is the intelligence which you develop on the front end. How to handle the failure. Are you getting how we are splitting things between the front end and the back end? Now, status codes are done. What are drivers?
Well, if I tell you more, drivers are more like APIs. I can tell you, because they connect you to some third party platforms or solutions that can help you in solving a particular problem. So if I be more specific, your application cannot talk to the SQL databases directly. Your applications cannot talk to MongoDB directly. So they need some middleman in middle who will, be the bridge between both of them. So that's why we call them as drivers.
So drivers are also a kind of API.
Yes. Yeah.
But to external APIs, not yours.
Yeah, it can be external and it can also be internal APIs. Like what if we run Mongo in a local?
Okay.
So then it need not go outside, right? He can.
So they connect multiple services in your own thing.
Yes. Yeah. Like for example, if I
Do
want
they connect
to
So what do drivers bridge, Shavan? What are the A and B which get connected by a driver?
A is your application and B is the third party source or some additional functionalities that you want to connect.
It could be your own functionality. It's connecting your.
Yeah, we can do that too. Like, no, that will be an API, more of an API. But
so then driver is always third party.
Yeah, most often they are third party because
so can you give an example of a driver to something which is of yours only?
Well, I don't have an example like that right now.
If it is your own thing, why is it not just an API?
I didn't get that.
If that function is yours, if that method is your own method sitting on your own server, why is that an API?
Because see, for example, okay, I can give you an example. So I have one application in Node.js and one application that handles AI stuff, right? So one is in Python, one is in JavaScript. So how do I communicate them? So then I can make one API and make them communicate.
So you're trying to communicate between one code base and another code base.
Exactly. And that might also be JavaScript. But if it's a JavaScript, then we did not make those APIs. We can integrate these as individual functions.
Okay. So drivers are like bridges between codes.
Some third
Where the
party.
application is not able to directly access, you use a driver to access.
Yeah.
So the way you write a driver and the way you write an API, are they the same or are they different?
Actually, we don't write drivers. They are given to us by those companies which services we want to use.
But what if you are the one who's creating the Python base and you are the one who's making the JavaScript base?
Then it's more of like our own application, not a driver.
But you still have to talk, right?
Yeah, then that's an API.
But you said it's not just third party, it can be internal also.
Yeah, by that I mean, okay, that was the example. Like MongoDB, we can have two things. One, we can set it up locally, or we can also use it the Atlas one that is hosted on cloud. So by locally, I mean, see, it's their drivers only. I mean, their software only running locally in our machine.
Okay, they give you drivers to use that.
Yes. I mean, the thing is same, okay? If it's running locally, we use the local host. And if it's running in cloud, then
so driver is like an API given by somebody else to us.
Yeah, your third-party source.
Okay. So people to look at it in a simple way, let us say that you're that cake making. Okay, let me give you my favorite example. So let's say you're in Hyderabad and you're eating biryani, right? You're a hotel which is making biryani. Now for biryani, you need those roasted onions. You add those roasted onions on biryani, right? So I'm a hotel which needs roasted onions. So then I'll call that roasted onion supplier and he gives me that roasted onions. Then I use that to make my biryani and then I sell it. Then I send it to my front end, right? So I'll need to make a call to that guy and say, hey, give me like 10 kilos roasted onions. Give me like 100 kilos roasted onions and so on. So your front end calls a backend and that backend does that specialized expertise and gives it to your front end, right? But is it possible that your backend can also call somebody else's backend to take specialized expertise of somebody else? Do you get what I'm saying? For example, let's say a deep thought wants to send a message on WhatsApp. We use the APIs given by Vati. So what do? We call Vati and we tell Vati, these are the phone numbers. This is the message. Please send it. We give them the request. So what happens? Vati through the API, it takes the request, it sends the message and gives us a response. These are the people where it was a success. These are the people where it was a failure. And this is what has happened. The status it gives us is a response. So we are making use of somebody else's API because somebody else has the specialized capability of delivering messages inside WhatsApp folders of people. Why are we not able to land messages into WhatsApp? Because Zuckerberg has not given us that access. Zuckerberg is only friends with Vati, he's not friends with us. Right? So what is Vati again doing? We are firing an API. We are calling Vati's API. Our front end is calling our API. Our API is calling Vati's API. Vati will call one API given by Facebook. Then God knows what happens inside Facebook. Facebook sends it to WhatsApp. And then it sends it back the response to Vati. Vati sends back a response to our front end, our backend. Our backend sends the response to our front end. This is how modern cloud computation is. It's not one company building things. It's multiple companies using each other's APIs and working, and you don't know. I mean, today almost every large company is using like hundreds of APIs. I don't know if you guys remember, but on LinkedIn, I was writing about it, that the future belongs to these API makers. There'll be a lot of companies who'll just make APIs for a living. Here is my API, 100 rupees per month, 200 rupees per month. Okay, not that low, but yeah, $50 per month, $100 per month. They just sell APIs. Saying, you don't have to build all these capabilities. I already know how to do it. You give me a request, I'll give you a response. It's like cloud. So this API businesses will be like cloud kitchens. I'll make the samosas. You sell it from your bakery. You put your brand name and sell. I'll only make samosas and give you samosas. You're understanding why I'm comparing API making companies with cloud kitchens. They create the computation, but the customer doesn't even know they exist. Because the customer is interacting with one front end, that front end is delivering that value to them. That front end may have so many things behind, which is going into creation of that value. Am I making sense? So this is how multiple APIs get interconnected in the backend so that we can use multiple capabilities to deliver that value. Again, here I want to tell you one story of business. Rajiv Bajaj, the current head of Bajaj Auto, somebody was saying, ban China, make in India and all. He said, why do you want to ban China? He said, why do you want to ban China? He said, China is only making the parts. But who's making the bikes? India. Where is the margin more? In the parts, raw materials, or in the fellow who's selling the bike? The fellow is selling the bike. Now, is Fardeen here? We got disconnected. Okay. So there's Bangladesh. Bangladesh makes a lot of t-shirts. They've got an excellent t-shirt making thing. T-shirts come from Bangladesh. But which brands sell those t-shirts? Indian brands and American brands. So when I was in college, I ordered some jerseys for my cricket team. So there was a local seller in Pune. He would order a lot of shirts from Bangladesh. And all colleges in Pune, whenever they ask for jerseys, he would print. He has his own front end, right? He prints. His back end is Bangladesh. So from Bangladesh, the jerseys come to Pune. He just prints them and he sells it to them. Who's making a greater profit, Bangladesh or this guy?
This guy, obviously.
The business which is front-ending makes more profit. Because they are the ones who are creating a brand and selling that experience to the customer. Unless the customer is a B2B customer, who's a wholesale customer, who's directly procuring from you. So Rajiv Bajaj was saying, why do you want to ban China? Why do you want to focus on the parts manufacturing? The profit there is not very high. The profit is much higher where the company is marketing it. You create a brand and you market it, the profit is higher. So the API makers may make a lot of money, but at the end of the day, where is the profit higher? The company which is B2C, the company which is giving value to the end customer. Deep Thought can be an API maker which makes an API and give it to Byju's. But Byju's will then make a higher profit because they are the ones who are marketing that whole thing to the customer. It's like you're a movie maker, I'm a theater. I make more profit. Now you demand 90% of the ticket price. I'll say, okay, take 90% of the ticket price. I'll earn on popcorn, you don't worry. You got what I'm saying, right? I'm the one creating the experience. I want more profit. I'm the one bringing the crowds into my theater. I'm the one doing the marketing. I demand more profit. That's the attitude of the company which is actually selling it to the end customer. Do I make sense? But then why will you be a backend guy? Why will you be an API guy? If the front-end person is making maximum profit, why do you want to be a back-end person?
You might use that data like again to create another front end as Zomato. Take the example of Zomato.
We are the creators.
We only specialize in technology. We are not good at selling it to customers. We do not want to get into that hassle of getting customers, distributing it to customers and all of that. So it's like saying, I'm the factory, I produce, I'm Parle-G, I make biscuits, that's it. My distributors come, they take away the biscuits from my factory and they sell it in the market. So I am the specialist who will create this. Let somebody else use it and deliver the experience to people. Like AWS, right? I'm the specialist who's creating a platform where people can host, where people can make things. Let somebody else make things with it and sell it to customers. Who will make a higher margin, AWS or the company which is selling to the customer?
The company.
But AWS
Company
still
is
makes
selling.
huge money because they're selling to huge number of people. They're supporting so many applications across the world. So now you're understanding why drivers would be required. Now, when I give you an API, I have to give you a driver. I have to tell you how to use these resources, right? I'm the one who's selling something to you. I have to also tell you how to use it, how to call it, a pathway to call it. So I give you a driver along with it. So you use, for example, let's say you're using MongoDB for storing your data, like how Shavan said. I also give you a driver along with my DB so that you know how to use my database. Because I am making it and giving it to you. When you use an external person's resource, you'd want to have the driver of the external person. Now, we finished drivers, we finished status codes, request, response, express router, routes. We have 3 concepts left. Okay. Now we'll go to sockets versus HTTP calls. Shavan, you know, I'm purposefully delaying middlewares and controllers. Okay. Sockets versus HTTP calls. So socket we've understood, right? It's like client and server continuously talking to each other. What's a HTTP call, Shavan?
HTTP call is more of a like an independent request that is made from your front end to the back end. And what happens in HTTP call is when a request is sent, it reaches the server, the connection is open, you get a response, and the connection is closed. And the
So your APIs are done through HTTP requests.
Yeah, the APIs work with HTTP requests.
Yes. So using Ajax, you do HTTP requests, right?
Yeah. So one session will be open, and you will get the response, and it will be closed. And yeah, that's the life cycle of HTTP requests.
Do you guys remember our discussion on me continuously talking to Aryan and me talking to Aryan only on a need basis? Now, let's say Aryan is going on a road and is super scared. He's talking to his mother. Is he going to be on phone continuously, or is he going to talk only when he wants to ask her something?
I think continuously.
So that he feels more courageous to just get through, right?
Yeah.
So there are places where you want to talk to the server continuously. Now let's understand what are the places where you want to talk to the server continuously. Now let's say Srijit is using WhatsApp. He's on a group. Ronak and Abhishek are on the same group with Srijit. Ronak goes and messages Abhishek. Abhishek goes and scolds Ronak. Srijit has done nothing. Would Srijit want to know about Ronak and Abhishek talking to each other? But how does the front end of Srijit know that I'm supposed to go and get something from the back end? Are you getting what I'm saying? See, it's something like this. There is something very exciting with now I am the back end. I can't talk to Sri. Okay, now Srijit, Ronak and Abhishek are my spies. They are in Pakistan and they're doing a mission in Pakistan. They're my spies. I am not allowed to call them, because if I call them, ISI is going to intercept all my calls and they'll catch them. Their cover will be blown. So only they can call me. Now, if I'm doing an important operation, what will I tell Srijit? Be on the call. Stay on the call. Why? So that I can monitor and give you live instructions. But otherwise, what will happen? I have to wait for Srijit to call me. I can't call him. I can only wait for him to call me. But let us say Ronak blasted a bomb in Karachi and Srijit is about to blast one more bomb and Islamabad is on high alert. Okay, sorry for the bad example, but yeah, let's say Islamabad is on high alert. If I'm, let's say the chief of this then what happens? Do I have to tell Srijit, quiet, don't do anything now? But does Srijit know to talk to me? He doesn't, because he doesn't know what Ronak and Abhishek are up to. So if I want a communication where I want all the three in the loop, irrespective of the Srijit's silence or presence, I want a socket. So that the actions of Ronak and Abhishek can also be triggers to send something to Srijit. Otherwise, I'm dependent on Srijit's front end talking to me to talk to Srijit. Your mobile app talks to Google's backend. Google's backend can't always talk to your mobile app. How will Google's backend know to talk to you? But if you have a socket, Google's backend can continuously talk to you. Or if you use Firebase and all and you push Android notifications, it can push notifications to you through your mobile. Or you configure Chrome notifications, it can talk to you through Chrome notification. For the backend to talk to your front end is not an easy job. What will happen if the world's backend always had an ability to talk to front end? The world will be a spam-rich world. Right? Every company in the world will send an advertisement to every bloody person in the world. So the backend, obviously, you wouldn't want it to talk to front end every time. You want the backend to talk to front end only when the front end requests. Because if I'm a consumer on the internet, I need to permit a website to talk to me. No. When I call a website, that's when the website talks to me, not when the website wants to talk to me. But what if the website says, for you to get service from me, I want you to keep the channel open for the next 1 hour. Then the user says, okay. And there's a socket which is open and the socket is continuously talking. Do you guys understand the difference between socket and the HTTP method now? If I use a HTTP method, I can only talk when the front end calls as a backend. But if I use a socket, my backend can continuously talk to the front end.
So the socket, is it like, the website sending you continuous notifications?
So there is one route or there's one place through which they're continuously talking to each other. If I'm the backend, I'm listening to you continuously.
Okay.
So this is more expensive, right? My bandwidth is going into listening to you continuously. If it's a HTTP, you make one request, only then I've listened. So the difference between socket and HTTP method, is it clear? Okay, now we have two more concepts. No, not middleware. Promise and callback. Yeah. Shawan, you don't go ahead and summarize difference between promise and callback.
Yeah. So, for example, if I want to make an API call, so would that be instant or will it take time? It will obviously take time, right? So then how do you make a call? So, for example, if I'm making a call from the front end side and the front end is waiting for the response, okay, he's waiting for the response. So what will happen? My browser might lag, okay, it might be unresponsive, waiting for the response. So for getting the response, okay, and not to, so the browser will continue working on, and like when I get the response back, then I can display it. So by that way, what happens? My browser is not dependent on anything. He works independently, and when the request is resolved, and then he displays the things accordingly. So this method, right? Like how we, so this is just an example, okay? This is not a definition. So, promises are basically kind of an asynchronous code that works on a separate, it works on a separate queue, okay? It works on a separate queue, and it only comes to existence once it's resolved. Got it, right? So, for example, if I am the person, okay, I am doing a job, okay, and there is something I'm dependent on one other guy. So what I will do, I will tell him, okay, you please give me that resource. And by the time he gives me the resource, I will keep on working on my part. And when I get the resource, I'll put it back to my stack and keep on running.
So what is this promise here?
So promises that call, I mean, promises something. I mean, if I give you more, I mean, a very easy example, right? Promise is something that runs on a separate queue, and it runs asynchronously.
How is it different from any other method?
I mean, see, any other method will give you the response immediately. I mean, if it's not a promise. But
Okay.
promise
when
is
will it give
asynchronous.
you?
Promise is asynchronous. Basically, it is used. So if I have a huge work to be done, right? A huge chunk of work to be done, then I use promises because I know that particular thing can take time. So I let him run on a separate queue and I keep on working on my step.
So let's say you're running, you're making an API. That API has to get records of 100 students and send it to the front end.
Yeah.
Would you use a promise here?
Yes, because getting those 100 students, right? I need to do I need to fetch them from somewhere. Some DB calls has to be made.
But even
And
in
as-
normal method, I will wait and only after I get, I'll be able to send the response. No.
Well, no, in normal methods, you can't do it actually.
Why?
Because you are fetching it from the database, right? So he again is to make call to the database. And okay, leave the database. We want to read it from a file. For example, that file is huge in size, 10 MB, 100 MB, something like that. So reading that file, getting the data out might take
So
some time.
does the API automatically send a response in some time?
It depends actually. So for example, if I want to send messages to 1 lakh students, then my API, then what I will do, I will let the promise run on a different thread, and instantly I'll give the response back to the front end.
My question is, if I don't use a different thread, they've called an API. What is the API supposed to do? All those 100 records, and it would get the 100 records and send it as a response. So once I'm called, I can't send a response anyway until I get the 100 records. No, my only job is to do 100 records. So why does it have to wait? It's anyway sequential, no, one after the other, no?
No, can you repeat that last part?
No, why do I have to wait? It's not a parallel task, no, it's a single track thing, no? Straight, linear, one after the other, right?
No, I didn't get the overall.
My thing is, someone asked me to get 100 records from a huge DB.
Yeah.
So now I got a request. All I have to do is do this job, and once this job is done, I'll go back and give it.
Yes.
So I'll anyway wait. No, I can't go anywhere. Right? So why do you have to tell me to wait?
Well, you have to wait because until I get those records, right, I can't give you the response.
No, I'll anyway wait. No, because I'll be able to give a response only when I have the response, right?
Yes. So
does the API automatically send a response after a certain time?
No, it will not send you automatically.
Then
You
why,
have to
what's the
program
point
it in
in
that
asking
way.
to wait? It'll anyway wait, no?
No, front end will not wait. I mean, that process will keep on running, but front end will not get stuck because of that.
Acha, so you're telling front end ki, I promise to give it to you. You carry on until I get it for you.
Yeah, it's the same concept of actual promises.
Okay, but what if you don't make a promise to the front end?
I mean, then he will. Then, for example, if the job is not done, then he will give an error, something like that.
Then does he wait until this is done?
Until what is done?
Acha, then he skips as per the DOM model.
He will
goes to the next one.
do that. Yeah, he'll go to the next one, and when it's
So
done,
then this
he'll place it
API,
back.
even if it sends, it's of no use.
Yes.
Okay, okay, now I get it. Tawfiq was explaining this. So you're a restaurant. You go to a restaurant. You order some exotic dish. You order some very rare dish. It takes 40 minutes to prepare the dish. So, but what the waiter will do? The waiter goes and tells that I want this dish. The waiter doesn't wait for the dish. The waiter goes on for the next thing in the queue and serves it off. But you make a promise. What do you make a promise to the waiter? That when this is ready, I'll add it to your queue, then go and deliver it. Because the waiter, JavaScript is Synchronous or asynchronous?
Synchronous. It's synchronous.
JavaScript is synchronous in the sense that I will not wait. That is why here you make it asynchronous, right? Am I right? Yeah, it is single thread. Because it is single thread, I do not wait. But if you tell that I promise, once it is ready, it will get added to the queue. Am I right with this concept?
Yes. Yeah. Meanwhile, it is happening somewhere else.
So I'm a waiter that, you ordered some, say, prawn biryani or something. That takes a lot of time for me to prepare. I don't have prawns in the hotel. I'll go to the market, buy them and make them. So by the time I make the prawn biryani, I will keep doing the other orders.
Yes. Yeah.
But if you didn't tell me a promise, I will ignore your thing and just serve all the other customers and not even remembering this customer. But if you tell that it's a promise, once that thing is resolved, I'll add it to my queue and I'll go and serve it. Am I right?
Yes. Yeah. These are the two states. Yeah. Resolve or reject.
Did you guys get why the promise concept is required? No, I mean the new guys. Saurabh, does it make sense? JavaScript is a single-threaded language. Means the DOM of JavaScript is like the waiter, where the front end is doing one task after the other task. Now, if the front end asks, please do this, and that is not done, the front end will treat it as if it doesn't come, the front end treats it as an error and goes on to the next task. But if you call it a promise, then the front end says, okay, fine. This is going to come later. I'm going to do all my other tasks, but when it comes, I'll add it to the queue and do this.
Okay. Yeah, so if to take the example of restaurant, so there are 4 dishes ordered. One is exotic, will take time, but till then serve 3 and tell ki 4 might come late, will take time, so we'll serve later.
So don't forget it, add it to your queue when it comes back is what you're telling through promise.
Okay.
It will be in the pending list.
Yes. And what's a callback, Shawan?
Callback is easy. I mean, it's not that tough. So what generally happens in a function, right? If it's a void, then nothing is being returned. And if you want to return something, then you do return, right? So what is a callback? So callback is a function that gets called automatically after a certain part of code is being executed. So now let me tell you how it works. So okay, so there is a function.
So is this callback any different from normal one function calling another function, or is it the same?
It's the same actually.
Why do you have a separate name called callback then?
Because callback, right? Call me back when you're done.
So is it like one API calling another API or one method calling another method? Or?
It's like one method being called inside one other method.
Does this make sense? It's kind of like recursion, right?
Yeah, I mean the name is the same only, like call me back when you are done with your stuff. Something like that.
So Ibrahim says it's an old version of promise.
I mean, yeah, some kind of yes.
Okay.
But not exactly.
I'll appreciate if you guys ask your questions, because I know we're going a little fast now compared to the beginning. Yeah.
Like in callback, we have to pass a function in an argument of another function, so that if the function gets completed, it will call the another function and then it will get executed.
No, see, there is a function. You pass one other function into that function. So the other function that you pass into that function, no, that's the callback.
So
because
Shawan,
that is going to get executed.
So Shawan, can I say, like, let's say I'm making a function which is going to get me 10 favorite items of Saurav to show him on his app. And I write a method which can get Saurav's 10 favorite dishes. And I write a method which can get me the latest price of those items. So get me the 10 favorite items of Saurav is calling another method which is get me the latest prices of these items.
Exactly.
So is this a callback?
That latest prices is your callback.
So you're using one method inside another method. Because you, as a backend developer, you're going to write a lot of methods, right, which do certain things. So when you write a lot of methods, you want to involve some of your known methods inside these new methods rather than writing the code again from the scratch.
And promises works with callback.
So which means through callback, you execute a promise.
Yes. Yeah.
Okay.
So is it something like when I say give the 10 best items or show sort of the 10 best items or 10 favorite items, it just does not just show the 10 best items but also with the latest prices.
If that is your front end requirement, then you want your backend to tell the items along with the price. No. I'm the backend. My only job is to supply the data to front end. The front end then delivers the experience. So as a backend, all I have to do is tell, okay, Saurav's items are bread, cheese, and buns. And I want to tell the 3 prices. You're right in that. I want to tell the 3 prices. So now I'm writing a method to get Saurav's favorite items. Now in that method, I write a separate method to get the price of that item latest.
Yeah.
So there's because that same method can be used in so many other situations to get the price, not just in his favorite items. That method can be used anywhere. No, get the price of this item.
Yeah.
So I already have a method which is capable of. So it's something like this in your company. So Sriparna is the favorites expert and Shagun is the market expert. She knows market prices of everything. So what do? I'm the front end. I want to know Saurav's favorite items. What will I do? Hey, Sriparna, please get me his 4 favorite items. By the way, please get the prices also and count. Then what would Sriparna do? She would call Shagun. Shagun gets the prices and gives her. Sriparna combines those prices along with his favorite items and gives it back to me. Or rather, Sriparna, let's say you are the person who's going to talk to me, right? You are the operations person who will talk to me. Shagun is the expert of prices. Anirban is the expert of favorites. So what do? You will call Anirban. Anirban gets you Saurav's favorites. Then you call Shagun. Shagun uses these 4 favorite items and gets the latest prices. You combine both of them and you give it to me and I show it on the front end.
Yeah.
So you are calling 2 other functions so that you can get your job done. Because those functions are already methods which are available to you. You use those methods to perform your task.
Got it.
Usually in APIs, what happens is, if I'm an API, I know how to understand a request. I know which methods to call using my request. And using the outputs of the methods, I take my response and I throw it back to the front end. As much as possible in APIs, I do not want to, inside the API, I do not want to write a method. I'd like to write a method separately, which is a specialist on how to do a task. I write a method separately, which is a specialist on how to write a task. And inside the API, I call the method. So that Sriparna's load is reduced. No, that code is somewhere else and that code can be used by anyone. I'm calling you for Saurav's favorites. Maybe Pooja is calling for today's trending foods. She'll call Sinjini. Sinjini is a specialist on what is trending today. And again, she'll call Shagun market rates of trending things. So Shagun is being used in 2 different situations. No. Now let us say Aryan is like choices for gifting to Saurav. He wants that. He'll also call Anirban to get Saurav's favorite options and he'll show it on the front end. You may want to gift any of these 4. Because what are the favorite options? That method can be used in so many places. No. Because it can be used in so many places, we write it separately as a function and keep it. So wherever that API needs, we can call this and use it. This is all a very neat way of writing your backend code. Does this make sense? So your callbacks come in because you want to call other methods. Or you may want to call a API itself, right?
Can you give the example of function in our preferred technology?
Let's say there's a leaderboard. The leaderboard wants the top 5 users and how many threads they have constructed in the session. So there's an API which gets called. That API, you make an API which can get the sessions, 5 best students and 5 best, the character count of each of the student. Now inside that API, I can write a method which gives me the 5 best students along with the scores. So this method can be used by this API in the leaderboard. And this method can be used in some other place also where you want this data.
For instance, L&D.
But if you are using the same data, you're doing the same work, then you may call the same API itself. API is the request and response dynamics. Method is what is the computation which is happening inside the API. Are you understanding the difference? Are you getting what is request and response dynamics? From an API, I get a request. I understand the request. I give a response. From a method, I get an input. I give an output. But I live inside the server. I don't work on the network. Method is you give me input parameters, I give you output parameters. But if I'm an API, you give me a request over the network, and over the network, I give you a response. So I depend on several methods to use the request as an input and give the response as an output. Yeah, Aryan?
So about the scores example, so if in one class there are 5 users, 5 top users, and then in another class there are 5 completely different top users, so would there be a same function for both? Sorry, same API for both or different API?
Yes, if your API is capable of handling different classes. So then you call your API with a class ID. Then pertaining to the class ID, the API finds out who are the top 5 students of that class, what are the character counts of that class, and sends that information. So for every class, you don't make a new API. You use the same API for all the classes. But you have a request parameter. One of the request parameters is you send the class ID, so that I know which class I'd like to search this for. Does that answer your question, Aryan?
Yes.
So the same code works everywhere, and I don't have to write too many lines of code. Okay, I'd like to just make a small, yes, Arup.
Like we talked about widgets. Like widget, can we connect widgets here? Like it's also the same line of code. You use it multiple times, like at different places.
Yeah, all of them are under one umbrella of a computer science concept called reusability. I would like to make something which is reusable, so I don't have to make it again and again. APIs are also reusable code, right? There are 100 companies doing the same thing. I'm saying, I'll do that for you. You guys pay me a small amount instead of making it yourself. That's what an API making company is doing, right?
Mm-hmm.
You all are doing the same computation. You pay me certain dollars per month. I will give you the API. Through my API, I'll do the computation and give it to you on the cloud.
When you say Shavan copy paste, like he's so fast because he copy paste, so he does this, right? Like he like there are APIs. His mind is he knows where.
He knows what to use where. That's it.
Yeah.
See, a lot of people are saying backend is tough. Backend is tough. I want to make a small remark here. Backend is not tough. Backend is a Mayajal. Backend is a difficult thing to understand initially. Once you understand what all is going on, it's a piece of cake because the number of lines of code usually on backend are much lesser than the number of lines of code on the front end. So initially, if I look at the face of Saurabh Bose and Sinjani, especially, they're like, what is this, right? But I think if you go over this 2 to 3 times, you'll understand that these are simple concepts. Once you understand the concepts, the code and the syntax is a piece of cake, especially because the number of lines of code on backend is much lesser than the number of lines on code on the front end. There's less writing to do, more thinking to do. Less writing to do, more thinking to do. Front end, on the other hand, needs a lot of writing. Because you're specifying a lot of things. But on the back end, the things already exist, they're already configured, you're just making use of them. Or some places you're configuring them. It might just appear overwhelming because you've suddenly been shown the entire Mayajal at once. But you pick each piece and you try to thread build and try to make sense of each piece at once. It's pretty simple. I don't code, and you see, I'm just trying to explain. You get the conceptual aspects right. I think executing this should be quite easy. Now, Shavan, let's go to middleware and controllers. Yeah.
Middleware is easy. Like, see, it's nothing but a security guard standing between your controller and your APIs, who checks, who validates the request, and I mean, he does the necessary job, what has to be done with the request, and then he forwards the request to the respective controllers. He's nothing, just a security guard and a validator.
Shaman, security guard and validator. Like, let's again build the context for this. Let's build the context for this.
Yeah.
Now, do you want unauthorized users to access your backend resources?
No.
Okay, are your backend resources expensive?
Yes, they are.
Usually, as a company, when you have to set up a server, it's expensive, right? You're maintaining a server. So every computation that your server does, is it a cost to you? So if you can stop the requests which are not needed, are you saving money? Now, Aryan is a school student. Aryan, let's say, is not allowed to access certain information on our website, which is of a company which is meant for only employees of that company. Now, Aryan is making the request. Do you want to call the backend process and make that process perform all that request, or do you want to first check if Aryan is allowed to access it? Because if you check that Aryan is not allowed to access it and you block him, you're saving some backend resources, right? It's like, you're a shop. Some person is coming and asking you quotation for 100 things. You know that fellow is a window shopping fellow. You don't even ask your team members to make the quotation, right? So you want to check if this is a request which I want to process or not. Now, what if front end is coming and asking me a request and they've not given me all the details? Do you want to start the computation? No, right? So you'll push an error back. So the middleware is the guy who's a validator who's checking, have you given me everything or not? Let's say you're giving me your date of birth and say, create my profile. You're giving me that response. Can I validate and say, boss, no, this data is not valid for me. So your API is not even running because your middleware has even said, this data is not allowed. So the same middlewares can be reused again and again. And the controllers are used to create the APIs, right?
Controllers, like what I explained in the very beginning, right? Controllers are those functions who will, will do the job for you.
Correct. So when you create the controller, you also add the middlewares into the controller, right?
No, the middlewares, they are like chain, okay? Here,
wait, what is that setup API function, or what is that function's name?
See, that setup API function is our internal function, like that we use in GT. But if I remove that, we just give the method, okay? And that method is a function, okay? That takes basically three things. First of all is the route that we define. The next part is the middleware, and the third is your control.
Yeah. So the method you define takes the route. Where do you want it to work?
The method, the HTTP method function, right? That takes the route, the middleware, and the control. Three things.
And the controller is the one which performs the request response dynamics.
Yeah, exactly. He gives you the response.
But the method which is called by the front end through the HTTP method knows how to validate through the middleware, knows where to go and ask through the route.
Because
and what is the third one?
Sorry.
It knows the route, it knows the middleware, and it knows the
controller.
Controller.
Like once it reaches the Express server, right? Now Express server will check, is this route present on my system or not. If it's system, then he will see the
Why do you have
controller.
to tell the controller that the route itself knows which controller to call?
Sorry, can you repeat?
The route itself knows, okay, on that route you call this method, is it?
Yes. I mean, we are binding these three things to for just one method.
Got it. So I think you will get more clarity when you go hands-on with this. You guys will get more clarity when you go hands-on with this. But I'd like to tell you why we did this workshop. The reason why we did this workshop is a lot of people just try learning syntax when they learn backend. But when you learn syntax, I think things don't make sense to you that clearly. But when you can understand the syntax through the concept and as well as the business context. Business context is, take one example, what is the business situation? What kind of technology do I need for the business situation? It becomes very easy to understand technology if you can visualize that technology through the business context. Like if you see all the examples I gave you, I explained you through the business context. That I'm Amazon, I need to do this to my client. And this is how I do it. This is why I need it. Because please understand one thing. Please understand one thing. All this technology that we have today, was made by humans like you and me. Do I make sense? So if that human created this technology, there was some motive which motivated the human to create this technology. Now, if I can understand that motive of why this technology was created, that can give me a deep level understanding of the technology. Do I make sense? So that is why I'm insisting that when you learn software engineering practices, learn them with the business context. If you notice, most of my time, I took it to explain you guys Industrial Revolution, then
Digital revolution,
then
and cloud revolution.
Cloud revolution. So that you can appreciate why there's a front end, why there's a back end, what's the business context, specialized expertise. Now you know why you want a client and a server separately. Then all of these things are a very intelligent way of making the client and the server talk, right? So now let's visualize what happens. I'm the front end. I use a HTTP method. Through the HTTP method, I hit a route. Then on that route, there's a controller. The route and controller, they work with a middleware. That middleware checks if I'm allowed to access, checks if I've given all the information properly or not. Then it calls that method on that route. Then that method performs that computation. It takes the request from me from the front end and sends back a response. Then me as the front end, I take the response and I give the experience to the user. Now, while I want to do this communication, I can do it through HTTP method or I can do it through socket. When I do it through socket, what happens? The communication can be seamless between front end and back end. But if I do it through HTTP method, it's only whenever the front end requests that I can do it. Now let's draw a mind map of all these, right? All the concepts that Shravan has explained us. Now here's the front end, because we are a cloud application, we have front end and back end. Here we have the back end, which is all the processes we have. And here we have the database, which has all our data. Now from the database to the back end, we get information through a driver. Now the front end uses a HTTP method to hit a route. And it's a method, a controller. The controller is what to do. Route is where to go. And a middleware to authenticate. Wait, Shravan, do you write your middleware in the HTTP method?
Well, we write it in the backend actually, and we write the middleware inside the HTTP methods. So the HTTP method, right? Like router.get, I mean our express.get or express.put. So inside that we write.
So you don't write the middleware. I mean, your middleware sits on the backend, right?
Backend, yeah.
So your middleware, route, and controller, all three sit in one method.
All three sit on the backend inside one method.
Correct. And the HTTP calls this method, right?
HTTP call, I mean HTTP request, right? To a particular endpoint. Yeah.
So what does the HTTP have? It has request, it has response.
It has request and response.
But it would also know where to go, right?
Now that's the API route, right? The
Ah,
URL.
it is a route. So then how does this method get called?
So we define these methods in our server, I mean our backend. And for each API endpoint, we write a method. So for example, if there is a get API, we'll write router.get or app.get. So that get method, inside the get method, we'll write the route, the middleware, and the controller. So we are basically logging one entry. Okay, we're logging one entry of a particular method. This is same like an Excel sheet. Like what we do for a particular row, right? We add a name. For example, if it's a student record, we write the student ID, the name, the roll number, and etc. That becomes a one record. Same in the server.
So you hit a route, let's say deepthought.education/Shavan. Then in your server, if I get a get method on this route, the server is told ki please call this method if you're getting a get method on Shavan.
Yes, our router will first of all check is this route defined, if I know about this or not. And if it's already defined, then I will pass the request to that.
So what is happening? Your front end is taught how to talk to the server.
Front end just knows the API endpoint and what method I have.
Exactly. Through the front end is talking to the server through the HTTP.
HTTP request to the
Yeah,
particular
the HTTP request, but do you have a response inside it?
No, HTTP request, like when it goes right, it just has the request. It
But
doesn't
when
have
it
the
comes
response.
back, it has a response.
Right. When it comes back, it has everything.
So my front end sends a HTTP method, which has a request and it has a route where to go and ask.
Correct.
But the server knows on this route, if I'm getting this kind of a request, how do I handle it?
Exactly.
And that method contains something called a middleware. But then why does that method again need a route?
No, we are defining the route inside that.
Okay, you just write the name of the route here.
Well, no, this thing is written in the backend front.
But your HTTP method already has a route. No?
But how will he know the route if we don't see this route is hard coded by us?
No. Deepthought.education/Shavan is what HTTP is saying, right?
Yes.
So your method, but your method is being called by the server itself, right?
Okay, let me make it clear. Okay, I mean simple one. So in backend, we define the route. Okay, we define the route deepthought.education/Shavan. We define the route. We gave a middleware. We gave a controller. Done. Okay. Now on the front end part, I am the route that I made, right? I'm giving the route to the front end part to make a call on it. So now when the front end calls, okay, to that particular route, it is first of all it's received by our Express server. Now our Express server will check, is this route present here or not? I mean, is it defined or not? If it's defined, then our Express app will forward that request to that particular endpoint.
Okay, you have a middleware, you have a route, and what was the third one you said?
Controller.
Controller is what to do.
Yes, what to do. Route is where to do. Middleware is like mixture kind of.
Okay, the server talks to the DB, to the driver. The server can talk to external APIs through drivers. So wait, all your 8 concepts have come here. Driver has come. This is a HTTP method. You can also have socket, but with socket you have continuous communication. So HTTP socket has come, driver has come, 2. Middlewares and controllers have come. Then
promises, callbacks.
Promises, callbacks have not come. Okay. Then
status codes.
Status code is basically when these two are communicating.
After
you will write a status code so that the front end knows what has happened. Then 5. Did we cover all of them in the mind map?
Yeah. We did. Request response we did. Express router.
Request response. Express router is basically what
server. Server, yeah.
Yeah, only promise and callback is not in this picture.
So why we have not included promise and callback is like this. These are used by I mean, everyone. I mean, even the front end can use that promises. The server can
That's
also
a
use
different concept, that is asynchronous programming.
Right, exactly.
But today let's focus only on this mind map. So what is happening? Your front end communicates with the backend. So your front end uses a HTTP method to talk to the server. In the server, there's a method. That method defines the route, and that method defines the middleware and defines the controller. So once the front end goes and hits the route, because the route already is, written here, that route calls this controller after this middleware is already checked.
Yes. I mean, first of all, it will go to the middlewares. Then
So when I hit that route accesses the method. That method accesses the middleware.
Correct.
Once the middleware approves, the method then
goes to the
accesses the controller.
Yes.
Okay, let's see a story of this. See, now let's say Sinjini is the front end. Sinjini has to sing a song. She's performing in a concert. But she doesn't know which song to sing because she doesn't know the audience. So Sriparna is a psychology expert. She can advise which song to sing. Satya Charan is the courier. Because he understands the language of Sriparna, he understands the language of Sinjini. Because Sriparna takes some time to understand. Now, what does Satya Charan do? Sinjini sends a request to Yashavan. Sinjini sends a request to Satya Charan. Then Satya Charan goes to Sriparna and tells ki, hey, this is what I want. Then Satya Charan has something called a route. So once he goes and hits the route, he hits the server of Deep Thought. When he hits the server of Deep Thought, he's hitting a route of it, right? deepthought.education/music concert. Got it? So Sinjini is performing a HTTP method. So when she's performing a HTTP method, she is hitting a route, deepthought.education/music concert or something. Now, what does the route do? On that route, let's say there's Anaka, the server. She checks, does this route exist? And if this route exists, on this route, for this kind of a method, how do I handle? That's declared on the server. We declare on the server, on this route, if you can get this kind of a request, please handle it this way. There are 4 kinds of methods of, different kind of methods which come. So once we define on the server, then what happens is, Anaka first runs a middleware. Let's say the middleware is Shagun. What does the middleware do? Is Sinjini allowed to talk to Sriparna? Now the middleware is she a paid user or not? Sinjini did not pay last month fees. Then Shagun says, no, I will not let you talk to Sriparna. First pay the money. Then Sriparna gets an error. You're not authorized. Let's say now that middleware is fine. She's authorized. But is she giving the request in the right pattern? Sinjini said, please tell me which song to sing. But she didn't tell which country she's in. Shagun says, invalid request, please tell me which country you're in. Then Sinjini performs another request and says, okay, I'm in Maldives, please tell me which song I should sing. Then Shagun says, approved. Now Anaka says, okay, send it to Lokesh. Lokesh is that method. Now Lokesh is the method who takes a request, which is, I'm in Maldives, which song do I sing? He does a computation and he says, okay, the latest song in Maldives today is this thing. Okay, please sing this. And it goes back to Sinjini and Sinjini sings that song. So why do you have the middleware? You want to validate whether the request is in a proper format or not. And you also want to authenticate whether this person is allowed to take this request or not. Why do you have a route? Because that's how your front end is communicating, right? It hits that route. Then your server knows that this guy is coming through this route. It is this kind of a request. The server first checks the authentications and validations. Then the server calls the right method. The method performs the computation. Now there can be callbacks, right? Where the API can call multiple functions to perform that computation and send the request. But maybe your own computation capabilities are not enough. You use help of other companies. You use drivers to call their APIs to perform the computation. Now, I'd like to tell something to the backend developers. Forget these 2 parts. Forget this part. Forget this part. Okay. This part will come later. Initially, if you can understand front end to server to this method, you'll be able to write APIs. You understand this part, you're done. How to write a HTTP method, how to write this method, how to write the route, how to write the middleware. So middleware and control also, you need not learn right now. A senior will help you do that. But if you know how to write a method and the route, if you know how to HTTP requests also, they're usually made by the front end. So you don't have to worry too much about that. If you know how to write the method, the route, and how to do DB operations, you're doing fine. But just have an overview of this entire Mayajal. If you have an overview of the entire Mayajal, the code is not complex. You just need to know the data flow, right? How is the entire system working? See, it's like, let's say you're working in a simple hotel. You're working in a simple hotel as a waiter. What do you know? I go to the customer, I take an order, I go to the kitchen, I say, give me this order, and I give it back. But let's say I work in a very complex hotel where there are specific places. You know, for dosa, you have to go to one place. For this one, you have to go to one place. For this one, other place. So there's very efficient systems. To learn to work in that hotel, will it be challenging? But only in the first week, right? Why? You're getting used to the system. So likewise, backend is only challenging the first week. Once you start writing some APIs, once you start writing some data models, it's simple. All you have to do is visualize this like a story and see what's going on. Can someone explain me this entire? Okay, Aaron, go ahead with your question.
So, by what Satya did, like as a courier, so is that equal to what a route does?
What? Sorry, Satya?
What Satya did as a courier, is that equal to what a route does?
No, that's the HTTP method.
Okay.
So using a HTTP method, the front end is talking to the back end, right? Sinjini is talking to the server. That is, Sinjini is talking to Anaka through Satya. So Satya is going and hitting the server on one route. Satya goes to Anaka and says, route this, request this.
What does it mean by hitting the server on one route?
See, it's like this. Anaka is the factory. Sinjini is the showroom. And Satya is the operations executive from factory to showroom. So there's always one person available in the showroom who can go to the factory and come. Right? So what is happening? Sinjini sends Satya to the factory. Then Anaka receives a route from Satya. What is a route? A URL, right? deepthought.education/which concert. Along with the request parameter. Then what does Anaka do? Anaka is already told, if you are asked information, there are different kinds of APIs, okay? Get API. There is an API which is asking you information from backend. There's an API which is telling you, please add this information to backend. There's one API which is telling, array from backend, get me this information. One more API is saying, array add this, store this information. Another API which is saying, update this information. Another API which is saying, array this user is an idiot, delete this fellow's data. Got it? If you're Amazon, you may want to add information to your backend. This user said, I like this data. Or you may want to get information from the backend and show it on the front end. From backend from factory to showroom, you may get information. From showroom, you may add information to the factory. Or you may update what is in the factory, the information coming from the showroom. Or you may delete what is in the factory. You no longer want it. So that is the kind of the request. So Satya goes with, this is a get API. This is a put API. This is a patch API. These are kinds, okay, which you'll learn in RESTful APIs. So Satya goes and tells Anaka, this kind of API, this route, this is my request. What does Anaka do? Anaka checks. If I'm getting a get API on this route, what do? I get API on the route, I'll call Shagun. I put API on the route, I'll call Saurabh Bose. a patch API on the route, I'll call Ronak. Which method to call for which kind of a request?
So is route kind of like a part of a server?
Route is that URL, right? Where you are hitting.
No, more like a street name, right?
Yeah, in a way you can say it's a part of a server, in a way. But it's not exactly a part of the server, right? You're hitting a name. On that name, when I'm getting on that URL, when I'm getting a request.
So like in the mind map, it's kind of first it's shown that there's a front end and then it goes to the server and then that it goes to the route. So,
yeah, to go to that server, you need that server street name, right? That's what Anirban said.
okay.
It's like the address of the house. House is the server. So the route is, so the whole server has one domain name usually. Then you have one route on that domain name. So I'm going to Anaka. Anaka is that server which is running this. So when I go to Anaka, which is a server which is running this, she's like, okay, this guy has come through this door. My server has many doors. This fellow is coming to this door. If he's coming through this door and he's coming with this kind of a request, I need to ask Ronak to help. If he's coming through this door with this kind of a request, Shagun. No, this is a different door. I'll call Sinjini. This is a different door. I'll call Satya. So Satya is the courier between front end and back end. The courier is done through HTTP method. Then the server through the route understands, okay, this guy is coming from this route. And this route, I'm getting this kind of a request. I have to call, first I'll authenticate with my middleware. Then I'll run my controller. Controller is what to do. The controller has multiple methods inside it. Now, if my controller has to talk to my database and get some information from my database to do my computation, it uses a driver. Why do you need a separate database and a separate server? We saw the warehouse argument, right? I want to store some things and keep. So you want your server to talk to the database, you use a driver. And they learn something called CRUD operations. When you learn CRUD, you're basically learning how to access things from the backend. That's pretty simple. In one day, you can learn that. HTTP methods, only for awareness of the backend developer. Usually, it's the front-end developer who does the HTTP method. You're a backend developer. What do you need to know? Someone hits a certain route. Anyway, senior developer sets up the API. You don't have to worry about that. Middlewares, you don't have to worry. Senior developer does the middleware. What do you have to worry? You write the controllers. The routes, the middlewares, all of them are set up by senior developer. What does the junior developer do? Write the controllers. So if you know how to write controllers and if you know how to do database talking, you're doing fine. You know how to talk to database, how to write to database, how to read from database, how to delete something on the database, how to update something on the database. Read, write, update, delete. If you know how to do those four on the database, you know how to write a controller, you're done. Then in stage 2, slowly you'll learn how to make the routes, how to set up the server and all of that. Stage 3, you'll learn more advanced things which you can write, more advanced controllers. Maybe talking to external APIs and using their drivers and making use of external APIs to perform your computation and so on. You can do it in stage 3. But you want to know one simple thing you guys have to overcome to become good backend developers? That fear which is printed all over your face right now. Where like too much is happening. I'll tell you, last Sunday I was learning backend with Shawan. I kept questioning him until I could understand. Not one point I felt I can't understand this. I kept questioning him. Shawan was telling so many things. He said, that you leave, you tell me what is this Ajax doing. That you leave, you first tell me what is this Ajax doing. He runs into something. No, wait. I first want to understand what's happening here. Okay, now I understand what your Ajax fellow is doing. So one by one, if you can question and understand this entire mind map, I think you'll be clear. But the first thing is, can you overcome your fear? Because Sinjani, the thing is simple. You overcome your fear, you learn all these concepts in 3 days. You don't overcome your fear, you learn these concepts in 1 month. You want to learn it in 3 days or 1 month, the choice is yours. Saurabhos, deal? Next month you want to learn backend or you want to learn AI? 30 days from today, you want to learn AI or backend?
Can you, sir, repeat it again?
You want to learn this basic backend which we just taught you right now, or you want to learn AI next month?
Yeah, obviously.
So you want to get stuck in the same thing, or you want to?
I want to progress.
Then what is the first thing you have to overcome?
Fear.
Go over this video again, draw the mind map again, understand things conceptually, you'll be clear. You want progress? So you want progress, I told you 3 things, okay? 1, overcome your fear. 2, understand them conceptually. You get what I mean by understand conceptually, right? Anyway, Satya and Aryan will explain what that means. 3 is see the business context. What is business context? Take a business situation where this is used. If you can take a business situation where this is used, you'll immediately get what is going on. Satya, Aryan can explain what it means to learn conceptually. Okay, Satya to ran away, Aryan, you can explain. Okay, now he'll come and shout, I didn't run away. Yeah. No, he really ran away. Yeah, Aryan, go ahead.
Okay, from my interpretation, conceptually means that you understand something by understanding it in small chunks and not actually remembering it, but understanding the reasoning behind it.
Not just reasoning, that's the rational. Conceptual understanding is, can you connect it with something else which you understand and get the idea there. Not remembering it, but getting what the idea is. Like when, see, API and all is new to me. So what am I saying? She's singing. She's the front end. She's facing the customers. She's the server. She has the specialized capabilities. But they need a courier, Satya. So when I'm linking it to something else which I'm very clear, I'm able to understand it better. Analogy is one way of understanding it conceptually. But trying to see what's going on there. Conceptual understanding, once you figure that out, you can learn a million concepts very quickly. And let me tell you one thing, the backend developers of Deep Thought will be working on interesting AI projects. We're going to get into very interesting AI projects by September, October. I'm personally working on some algorithms for AIs. So once you guys pick this up, I think very exciting things to do. So what are the 3 things to make sure you ace through this backend?
Overcome the fear, then make the mind map. Make the map in the mind.
See it like a story. With a mind map, see it like a story. And the third thing?
Take business situation where it is.
Take the business situation where this technology is used. Why is this technology required? Because the technology is built for a business need. There are certain business needs that technology is built for. Once you understand the business context, tech becomes a piece of cake. Do you guys know the difference between exceptionally good developers and average developers? They exceptionally good developers get the business context. Because the business, anywhere you want to understand the code really well, understand from the business angle. What does this guy need to succeed? How do I help this guy succeed? Okay, we'll listen to some reflections and close this workshop. Reflections, people.
we have to understand the need of the thing, like for what reason we are going to do it.
Okay.
One thing I think that came out of this workshop, like for me, which was the most important part, was how all these concepts sit together and interact with each other. That is, I think, while I was going over these concepts, that was the like most difficult. Yeah, that was the difficulty that I faced. Like, how are all this so many words with so many concepts? How are they sitting together?
Okay. Yeah, Aryan.
So I think today's session was kind of kind of an example of how we use conceptual understanding. How do we kind of learn what we consider as complex topics as easy manner? So today I kind of learned some methods for it. First is that you understand the context it's being referred on or what's the need of it. Like we also go on a little back on the history by industrial revolution and all, and by that picking up the reasoning behind it and then understanding that how it exactly functions. Like we also made a mind map and the concepts we learn about specialization and all from it. And the second thing I learned was about the mindset we take while we are learning it. So if we want to, okay, that's not it. Okay, so yeah, that's all.
Yeah, Lokesh.
Actually, what I want to say from today reflection is I am in second year of engineering or BTech, and I realized today what is the importance of engineering and why do we learn engineering. So first, when you started talking about software engineering, then I realized why do we need software engineering and what are the things which are needed to become a good software engineer. And second thing, I was trying to learn the backend, and I also started Node.js and Express framework from the last 2 months, but I cannot get the concepts. And I just read the code and type it in the editor, but no results were expected. But when you help and connect with the logics, I can get the concept and believe that I can learn it within 15 to 20 days like this. And most of all, I like the very good thing is that we first overcome our fear of learning.
15 days is too much. 1 week is enough. Yes, Saurav.
Yeah. So here again, we understood why understanding evolution of a concept is very important. Like how one concept it moved from industrial revolution, it went into factory. The set of factory, then why backend, like we related it and it was easier to understand. Then we, like what we did is we break down things. Like we break down what is one thing, what is other, then we connected. And for that we use various examples for bakery, restaurant, or let's say then the singing example that we use them, and that helps us understand. And another most important thing, not only for backend developers, but as we have discussed, for everyone in the company needs to understand the business context, for in which in why we are doing this. We are doing this just because we are told, or there is larger meaning to it. So understanding that, and to fulfill that need, we are building L&D. Through L&D, we'll understand the business context of company. It will be easier for our clients, our employees, to understand the, what do you say, business concept of the company. So
Sure. Next Sunday we'll have a workshop on what is this business context and why is it such a powerful thing to think through the lens of business. When you can understand business, you can understand a lot of things in the world, business and economics. Why? I mean, not just from a greedy lens, but also from an impact lens, like the Porter and the Drucker way. When you understand business, you get the hold of the thing. Yeah, Shrikar.
Yeah. So I would like to reflect on the process that we took. So that learning through building stories and so I visualized it like there is a location and some things are happening in different areas. There is a need, there is a situation that has arisen, and there are certain characters involved. So each character has some roles to play and how they are, coming together and forming that whole, the plot is being formed, that whole story is coming together. So yeah, that was pretty interesting. And understanding this, like we can isolate the different things like sub stories, and then we can learn each of these things. We can add more characters and slowly build our understanding. So yeah.
And the biggest challenge in learning backend is that you have too many characters initially. That explains the intimidated faces of Saurabh Bose and Zinjini. Because while the others are like, okay, I'm coming, I'm listening to a story, I'm going back on Monday. Like, okay, I need to actually code this tomorrow. And let me figure out how I'm going to code this tomorrow. Right? So, but I think the moment you understand that the only intimidation factor, and surprisingly, Ronak is not intimidated, he's like, chalo dekh lenge. So, which is the attitude actually. So, because I think it's once you know the different characters and what they're playing, I think it's seamless. But the challenge is, that's what Shavan is saying, backend is so easy. I don't know why these guys are scared. That's what I was saying. I think this backend is a Maya Jal. I mean, it's like there seem to be too many things going on. Just to be honest, Shavan, I was frustrated when you were trying to explain me the first time. Like, kya ho raha hai yahan pe? You see, I was not listening to him like a story, okay? I was looking at his code base and I was trying to understand his code base. I couldn't make sense of the code base. It took me like an hour to get a sense of, acha, okay, this is what is going on. Fine. Because see, I understand programming. You show me syntax, I can understand that. But what I was not able to understand, what all are you making? What are these pieces? How are they connected? How are they going to work? That was what was tough. But there again, see, generally a piece makes sense when the business context is understood. Because then intuitively it builds into you, okay, this is why I'm doing it. Fine. It becomes very natural. It kind of becomes a part of you. Does that make sense? It becomes a part of you. When the concept becomes a part of you and it gets inside you, when it gets inside you, you don't struggle with it. So we're looking forward to building a kick-ass backend team in Deep Thought. So, and I hope, we'll convert this also into a training module where each one will take one small piece and make a module of this. And that way, I think, because this is the first backend training session we're going to give anyone who's going to, get into the world of backend. So we'd want to redo this session with smaller chunks. So each one can take a small chunk and learn it. Okay. Thank you everyone for joining, and thank you, Shavan. I think everyone is quite excited about learning backend now, except for the two folks who were supposed to code. But probably even they'll pick up the excitement of backend soon. And Ronak seems to be quite pumped up, and I hope he assists through the backend training. Right. Thanks everyone for joining.
Thank you and bye.